Bismillahirrahmanirrahim. This is Sophia Suhail is here. Assalamu alaikum, my dear students. So today I'm starting the topic of higher derivatives from differentiation. Okay, that first time if you know how to derive. So second time I told in my previous video. Now third derivative and fourth derivative. How to take that one in this video? I will completely explain that. So first case which I have selected, that is when y is equals to, means any function is equals to sine of 3x, means trigonometric ratios I have taken in which the angle have a coefficient. So find out y 4. Okay, so 4 time we have to find out the derivative. First derivative, d by dx of y and d by dx of sine of 3x. Write down like this. Now first derivative will become y1, and here derivative of the sine angle, you must keep in the mind simple function that derivative of sine x is equals to cos of x. This is the simple derivative of sine. So derivative of sine 3x will be cos of same angle, and then derivative of the angle, that is 3x. Means this angle will be repeated same here, and then derivative of that angle you have to take. Okay, because here also in the simple statement we are omitting this step, because dx by dx will become equals to 1. But when the angle is other than x, so please write down the derivative of angle. It's a must step to do. Cos of 3x. Now derivative of 3x, 3 is coefficient, and dx by dx we can write 3 coefficient. I would like to write in the start cos of 3x, and this will become 1. Our first derivative is ready. Please highlight your first derivative. This is your first derivative. Okay, or you can write as equation number 1 as well. Now differentiate again. I'm just putting these two lines. It means that therefore we can go to the next step, that take the derivative again of y1, derivative of the complete function, write down as it is. Now derivative of the y1 will change to y2. 3 is coefficient or constant number, right in the start. Now derivative of cos. What is the derivative of cos? D by dx of cos of angle x equals to minus sine of x, and then dx by dx. This you can give the reference and you can use this relationship. Using it, it will become derivative of cos become minus sine of the angle, that is 3x, and then derivative of the angle 3x. Okay, minus I can write in the start 3 sine of angle, derivative of 3x become 3. So this 3 and 3 I can write as 3 3s are 9 sine of 3x. This becomes the final relationship for the second derivative. Again I will highlight this also and write down as equation number 2. Now again we will differentiate, because we have to take the fourth derivative. Derivative of this function, apply derivative on both sides. Applying over here I am writing this minus outside. Okay, 9 sine of 3x. So it will become, this will become y3, and here it will become minus 9, stay outside. Derivative of sine is cos of angle, and then derivative of angle, that is 3x. Minus 9 cos of 3x, derivative of 3x is 3. Again this 3 will go in the start and multiply to this. 3 9s are 27 cos of 3x, and this is the third derivative ready. We can name this as equation number 3. Again we will take the derivative of y3 that is minus 27. Now constant number I'm writing out of the derivative because derivative will be applied on the trigonometric ratio. Minus 27. Using the derivative of cos derivative minus sine of the same angle, and then derivative of angle. Derivative of cos is minus sine angle, derivative of angle. Minus minus plus 27 sine of 3x, and derivative of 3x is only 3. This again 3 will multiply to 27. 3 sevens are 21, 2 left, 3 twos are 6 and 2, 8. Sine of 3x, and this will become y 4. So fourth derivative is ready over here. And in this way, I find out first, second, third and fourth derivative. Okay, there was only one ratio, one trigonometric ratio involved in this one. So every time one trigonometric ratio, every time the derivative of that trigonometric ratio is being taken, and then angle derivative is being taken. So first, second, third and fourth derivatives are ready so easily. Okay, next question I will take, that in which product of the trigonometric ratios can be involved. Okay, so for that one I have taken the next part. If you have the function of y in the form of cos of cube x, now power rule, power is there, means cos of x you can write with the whole cube. So derivative, when you are applying the derivative over here, derivative of this function, so power rule will be applied because as a whole power is there. We will apply the power rule, this will become y1, and power rule is saying, means derivative of anything with n power, power in start, power reduced by 1, and derivative of the function, this function under the power. Simple function. Okay, this is the power rule. I just repeat over here. This is the power rule which we will use here, according to which power in start, power minus 1, and derivative of the function, this function under the power, that is this function, cos of x. Okay, now we will write 3 times cos of, this becomes square x, and derivative of cos is minus sine of angle, and derivative of angle. Angle is only x. If there is the value other than x like 2x, 3x, 5x, ax, so ax will be repeated here, and derivative of that ax will also be taken after that. Okay, so this will become minus, I will write in the start, minus 3 cos of square x and sine of x, and it is 1. This will become y1. Now if we are applying the derivative again on this one, it will take the product rule to solve. Okay, so before that we have one more strategy, that if we can convert this trigonometric ratio as, if we remember, we know that cos of square x can be equals to 1 minus sine of square x. If we are using this technique, so instead of the product rule, we have to use only the same, means every term will be differentiated separately. Okay, so I will suggest to use that one strategy. Instead of cos x, write down its identity, 1 minus sine of square x multiply by sine x. What happened with this one, that sine x when multiplied to this one, minus 3, and sine x, means they both, this and this, first multiply to this term, and they both will multiply to the second term. Okay, minus 3 multiply, and sine x multiply to sine of square x. Okay, I write minus 3 multiply and sine x multiply to first term, then to second term. Now I will write it minus 3 sine of x minus plus 3 sine of cube x. Yeah, what happened with using this technique, that our two terms are again Means product term is again changing to sum or difference term. Okay, so it's easy to differentiate the terms in this condition as compared to the product form. Okay, now we can take its derivative of y1 and derivative of this complete expression plus 3 sine of cube x. Okay, what happened here? Minus 3. Derivative of sine, I am writing it shortly or directly. Derivative of sine is cos. Plus 3. Derivative of this is power in start, power minus 1. That will become square. And derivative of sine, that is becoming, let me write that first. Okay. So, first step derivative is this term. First term derivative is this one, and second term complete derivative is this one. Let me write that on the next page. Yes. So this one side is becoming derivative of y1 change to y2 and derivative of sin x, and then derivative of sin x become cos of x, sin square x cos of x. Now this will change to minus 3 cos of x plus 3 3s are 9 sin square and cos x. Can we write sin square again, changing into the identity, which is that sin square x is equals to 1 minus cos square x. We know this identity, so we can use it. 3 3 is 9. Instead of this, I will write this identity into cos of x. Open this bracket, minus 3 cos of x plus outside number this and this, multiply to first term, then multiply to second term. So 9 cos x multiply to 1 and minus 9 cos x multiply to cos of square x. Okay, minus 3 cos x plus 9 cos x minus 9 cos of cube x. Cos x, they are like terms, so they can be solved together. So their coefficients are 9 minus 3. 9 minus 3, 6 cos x. These two are solved like this, and minus 9 cos of cube x. Again we solve our equation and we get only the terms, single term and the single term again. Instead of the product, again we change the product term to solve to give a single term. Okay. Now y2 is obtained. Let me highlight that our y2 is obtained like this. If you need to stop till, if you need to find out first derivative, then first derivative is done here. Here first derivative was done. Okay, in this form, whether in this form or in this form, this is also okay, and this formation for the first derivative is okay. First derivative. Now the second derivative, this is done. Second derivative is done. Now for the third derivative, we will take the derivative again. Let's take the derivative again. y2, derivative of this term 6 cos of x minus 9 cos of cube x. 6 cos x derivative is minus sine of x. Okay, minus 9. Derivative of this term means the power rule will be applied. Power in start, power decreased by 1, so it becomes square. And derivative of the cos without power, that is minus sine x. If you will do and if you will make a practice, now you will have a good practice that you can find out the derivative directly. That write down the coefficient. Derivative of cos x is minus sine, minus 9, and derivative of cos x, power in start, power minus 1, and the derivative of this function right here. Okay. Minus 6 sine of x minus minus plus 9 3s are 27 cos square x and sine single x. Again cos square x can be changed with the same identity. y2 is derivative, y3 is done. Minus 6 sine x plus 27 1 minus sine of square x and sine x. open the bracket, plus 27 multiplied to first term and second term also, and sin x also multiplied to first term and second term. So 27 sin x multiplied by first means 1, that is equal to this one, plus minus minus 27 sin multiplied to sin square. So 27 sin and sin square become sin of cube x. Okay, now these two terms are like, they both have sign. So it means that we can solve their coefficients together. 27 minus 6 is 21, positive 21 sine of x, and then minus 27 sine of cube x. This is the complete derivative. Third derivative is solved here. Okay. Now for the fourth derivative, we can take the derivative of this equation again. Okay. So derivative of y3, we will write that here again take derivative of y3, and the derivative of the equation for the y3, that is 21 sine x minus 27 sine of cube x. Is that okay? This will become y4, fourth derivative. Here 21, derivative of the sine is cos of x minus 27, its derivative. Again apply the power rule, power in start, power minus 1, that becomes square, and derivative of the function sin x without power. Okay, so this becomes 21 cos of x minus 27 3s are 81 sine square x, and derivative of sin x is cos of x. Okay, here what we will do, again change the sine square, write down its identity. 81, its identity will be changed to sine square equal to cos 1 minus cos square x and cos of x, minus 81 and cos x multiplied to 1, it will remain same, minus minus plus 81 times cos square and cos 1, cos of cube x. Okay, now we will, as these two are the like terms, we will solve their coefficients. 81 minus 21 is 1 minus 1 0, 8 minus 2 6, and the sign is negative. Cos of x plus 81 cos of cube x. So this is our fourth derivative completed. Until here, I think you will understand this procedure of taking the derivative one after the other. So I have taken just in a very nice way that first time how you will take a complicated type of the trigonometric ratio if it has the power. So don't forget, if the question have a power, so taking the derivative means you have to apply the power rule. Okay, power rule you have to apply if your trigonometric ratio have a power over here. If the power is over here, it means the power is only on the angle, not on the function. If the power is here, it means this is the function power. If power is over here, it means that this is the angle power. This is the function power, this is the angle power. In both the cases, that power rule will be applied. Here overall power rule applied, and here overall derivative of cos you will write, and then when you are writing the derivative of this angle, then power rule applied on the derivative of the angle. So do a practice that, find out the derivative of sine of cube x by your own self, and find out its y4 also, and then check that whether your understanding is clear regarding the topic or not. Okay, until then, subscribe my channel if you like my video, and thank you so much. Allah Hafiz.